Hi, everybody. Thank you for joining us for this very special conversation with geologist Dave Tucker from Bellingham, Washington, associated with Western Washington University. And it's happening now. I'm making these video programs in the field, hoping that some geologists will notice and contact me if they have something they want to add. And that's exactly the case with Dave. Dave saw the recent posting of Goat Rock's tephra with Hannah Shamloo. I got an email a couple days later from Dave. Haven't heard from Dave in a while. And we'll just roll with what he knows about calderas in the Cascades. Dave, what's the weather report up there in Bellingham today?
Well, outside it's raining, but
Okay.
it's always raining
Yeah.
unless it's not. And
Right.
the wind is blowing like crazy.
Well, there we
So
go.
I'm inside. I'm
You're,
inside today.
you're inside, and I appreciate your time today. This is really fun to chat with you in this form. Let's jump right into it. You know a lot about the Hannegan Caldera up near Mount Baker. Um, do you have a photo you could share right off the bat to get us into it? I think that image might get us into similar things that we were talking about with Hannah, and then your research as well. So let's give that a try if you want to hit your share the screen button. I just got a glimpse
Okay.
of this with Dave. We were testing this out, and I just about lost it when I saw this photo. If it appears, there we go. Okay. So please, what's the story with this photo? When was it taken, and what did you know about the Hannegan Caldera when you clicked your photo? You clicked your camera at that point.
This is the south face of Hannegan Peak, taken from Hannegan Pass, reached
Wow.
by a 4 mile backpacking trail.
Okay.
It's east of Mount Shuckson, 5 miles or so.
Okay.
So this photo may have been taken in 1994, but this is what I saw when I hiked in here with Wes Hildreth of the USGS. I was a fresh faced field assistant for him in 1994. I knew almost nothing about geology. Wes asked if I knew where Hannigan Pass was, and I did. Why? He said, I'd like to see the Hannigan volcanics. And I said, well, I don't know what there is to see, but let's go. So we hiked in here and we got up to Hannigan Pass, and blammo, this smacked us in the face. I'd backpacked here before, but I hadn't really known, really what this was. Wes saw this exposure. This is maybe 800 feet from top to bottom.
Ah,
And he gave this outcrop his very highest accolade, which is pretty fancy, quote unquote.
yeah.
I said, what are we seeing? And he said, we are seeing your master's thesis.
Oh God, no kidding.
I didn't have an undergraduate degree in geology. I had hardly ever studied geology. So that kind of blew me away. I'd only known Wes 2 weeks.
Well, I'll tell you what, Dave, let's I want to hear more of your personal story since you brought that up. But before we lose this slide, can you use that little white pointer that you have, which I think, yeah, there we go. Can you just flash forward in the story to after your results? Can you break down this outcrop for us? What can we look at the top, at the bottom? What kind of units are we looking at here?
This is the uh, fill fill deposits of the Hanigan Caldera,
Mhm.
3.72 million year old caldera in the North Cascades, previously undescribed at the time I was looking at this with Wes.
Wow.
So the caldera collapse structure is filled with rocks, ignimbrite or pyroclastic deposits that erupt during the subsidence of the caldera.
Uh-huh.
So what we're seeing here from, let's start at the bottom, is all the talus from this stuff collapsing and accumulating.
Thank you.
Inside here, and the darker bands down here are uh, somewhat stratified um, pyroclastic flow deposits that are sequentially filling the caldera as it subsides.
Okay.
The pink stuff is also the caldera fill. It is welded volcanic ash.
Huh.
So this stuff was so incandescently hot that it was welding, meaning it was essentially turning into rock as it was deposited.
Yeah.
So hot, not like lava, but same temperatures.
Yeah.
The W-shaped bands we see here are post-caldera dikes that intruded the caldera.
Okay.
And they look like W's because the dikes are essentially vertical and there are subtle gullies here. So we're seeing topographic expression of a tabular dike that looks, you can see there's a little rib here.
Uh-huh.
So we're seeing higher in the dike here and we're seeing low in the dike here. So it's a topographical trick.
I see.
It's really a tabular structure.
Huh.
And then as we progress higher up, there's this dark band over here. This is a landslide deposit from the wall of the caldera that slid into the caldera as the caldera is collapsing
Wow.
over a very brief period. We're talking this entire collapse took place, I don't know, in a couple of days,
Huh.
a couple of weeks.
Uh-huh.
So this is a landslide deposit that's then buried by subsequent um, um, caldera filling rhyodacite uh, deposits.
Yeah.
And then the gray stuff is not welded. It is the same as this, only not as hot. And so it's not as oxidized. So it's a complicated story. It would be probably improved if we had some diagrams I could show about how calderas collapsed, but maybe we'll go there a little later.
Well, yeah, let's stop your share here. I'd like to get two heads back on screen. I'd like to flesh out the history and the timeline with you personally, and then we can go back to some of that detail. Um, you seem to have a pretty unique story. I don't know that much about you, but it seems like am I correct that you got a bachelor's degree long ago and then returned to school much later and got into this master's work in geology?
Yes, Nick, I started out in forestry in 1968 at UW and transferred up to what was then Western Washington State College
Right.
to the Environmental Studies School, Huxley College of Environmental Studies. And so I finished my undergraduate degree in 1972 at Huxley College. I took a couple of geology classes because I was a mountaineer and I wanted to know something about the rocks I was climbing on and why some of them were so good and why some of them were so bad.
Mm-hmm.
At the time, I had two qualifications for rocks, good for climbing and not good for climbing. My academic career as an undergraduate was nothing stellar. My wife later described my undergraduate career as a dry place between climbing trips. But so then like I said, I went into just being a working stiff and trying to earn a living and did carpentry and roofing and was a sailing instructor and worked in a sewing shop and um, lots of odd jobs. I was a professional mountaineering guide for quite a number of years, which is kind of indirectly what led me into geology.
Yeah, so you got somehow on the trail with Wes Hildreth, one of the experts in Cascade volcanism. Did you invite him at some point, or did he know?
Yeah, that happened because my wife Jill and I were teaching a glacier travel crevasse rescue course on the Coleman Glacier, Mount Baker,
Huh.
1994. And one of the students in the class was a geology professor from Western named Liz Shermer. And I got to talking to Liz and found out why she was taking this course, because Wes was coming up from Menlo Park to begin his Mount Baker mapping project, which also included his description of the previously unknown Culshan caldera.
Mm.
And he needed someone to get him up the glaciers of Mount Baker. And that's why Liz was taking the class. And I said, well, that sounds like fun. That very evening, I got a phone call from Wes Hildreth, who I knew nothing about, but turns out it was kind of like talking to God. And Wes engaged me as a volunteer guide on Mount Baker. And I ended up, and also Jill, working with Wes sporadically for the next 7 field seasons as a volunteer.
Huh.
But like I said, that very first year, Wes asked me about the Hannegan Pass and Hannegan volcanics. He had learned something about the volcanics from a very early North Cascades reconnaissance study by the USGS that just talked about the Hanigan Caldera, Hannegan volcanics, not the caldera, but from the thickness of the deposits, Wes is already guessing caldera, thick caldera fill.
Thick caldera fill. So is that so? Let's talk just generally about calderas in the
Sure.
Cascades to this point. Like I'm a newbie with this concept. Um, are we usually talking about thick deposits inside of a caldera, and rarely with calderas in the Cascades do we have fill outside of these rims?
Right. So calderas, are very thick deposits of pyroclastic material, ash and hot ash flow deposits that fill the caldera as it's subsiding to hundreds or maybe even thousands of meters thickness. That what flows outside the caldera, that ash flows that flow outside the caldera, are fairly quickly stripped by erosion, especially in the Cascades, where we've had profound
Yeah,
glacial erosion.
yeah,
And with a caldera like Hannegan, which is approaching 4 million years in age, there have been multiple glaciations which have stripped perhaps a full kilometer of the surface away.
yeah. So
We're only seeing what is deposited within the caldera structure.
that works for me. Yeah, the floor is dropping out. We're bettering our chances of preserving that stuff.
Yeah. And then if you have sufficient erosion, then you cut down deeply into these deposits, as the case of Hannegan Caldera or the Culshan Caldera on the east side of Baker. And so you get to see these wonderful exposures. The nice thing about a place like Hannegan is it's been exposed so deeply that it's a classic cross section of a Cascade caldera, the best
The
that we
best.
have, the best that we have.
So you can pass on this one, but I guess my next obvious question is the history of this. Like, was anybody talking about calderas in the Cascades prior to 1980 or something, or prior to Wes's career? Like, I don't think I've run into that concept
Well,
in these,
Crater Lake, of course,
right?
is very young and has not been eroded away, so we can't see what's inside Crater Lake.
Yeah.
Um, other than that, no real studies identifying calderas. There are some suspicious deposits that individuals thought about as possible calderas, but we really didn't understand calderas very well, even in the early 1990s.
Yeah.
At least not in the Cascades. They hadn't been recognized.
So starting in the 90s, at least with you collaborating with Wes, how many calderas are now known in the Mount Baker neighborhood?
Well, there's two. There's the 1 million-year-old Culshan caldera that Wes wrote about in 1996, and at the time, totally unknown, unrecognized.
Yeah.
Um, and then the Hannegan that I published on as my master's thesis, and then published a paper in 2004, which is the second one. So those are the ones we know about for sure.
Yes.
They're just to the north of Hannegan is an even older structure that is almost certainly a caldera, but has never really been um, the necessary field work has not been done at the Big Bosom Buttes, east of Winchester Mountain and north of Hannegan.
Okay. Well, viewers, I have a paper that Dave published, and that's going to be on my website when you see this video. So if you go to nickzentner.com and click on Cascades in the upper right-hand corner, look for a paper from Tucker on the Hanigan Caldera. Dave, did you have that other slide you wanted to show maybe that would give us a map view of these structures? And we'll just keep going with this. But
Sure.
it's really fun to talk to you directly. I haven't chatted with you in a while. I'm so pleased that you kind of popped up in my inbox. That was such a
Well, this one is the location map, so you
good,
can see where we're talking about.
good.
Scale at the bottom there. Um, so the red up here is the Mount Baker volcanic field
Yes.
that Wes has published on. The green is the Culshan caldera, right on the margin of the Mount Baker field. The stippled pattern is the Chilliwack batholith that Jeff Tepper has talked a lot about.
Yes.
And he and I are kind of connected on the Hannegan thing as well.
Uh-huh.
And then this beige or orange area is the exposure of the Hannegan caldera.
Hmm.
So that's the location. It's very close to the border. You can see the approximate outline is about 5 by 8 kilometers for the caldera. So let's look at another one.
Good.
And this is how the caldera collapsed.
Okay.
Is it showing up here?
Not quite. I think we still need that share button or
Let me
maybe.
go to the share button again. Okay, I made it go away. I'll find it again.
Okay. Okay.
Uh, also, so let me tell you a little bit. This Culshan caldera
Yeah.
has an interesting collapse pattern in that it is the caldera is not a simple like a piston structure that collapses.
Okay.
I'm not getting that image.
It's
I'm
okay.
sorry.
It's okay. Yeah, it's fine. Yeah, let's just keep
Right.
going. Yeah.
Yeah. Okay. So the I got stuff bouncing all over my screen.
Oh boy.
Sorry.
It's okay.
Are you seeing me now?
Yep, totally. Yeah. Yeah, let's
Okay.
let's just create some images kind of verbally here. So I'm imagining this piston thing exactly as you described it, but maybe that's not what I should be visualizing.
Right. So what happened at Culshan,
Yeah.
excuse me, at Hannegan is there was two phases of collapse,
Okay.
and it's called the trapdoor collapse. So instead of a piston subsiding like this,
Yeah.
and with this seating gap being filled with eruptive products, first it trapdoored like that, dropped down on a hinge essentially.
Okay.
And so all this area is filled with the caldera eruption deposits and the landslide deposits and all that stuff. So it's at an angle. The caldera then collapsed again, like that.
Wow.
So the original structure was like this,
Yeah.
with the fill being underneath my hand here.
Right.
And then the whole thing collapsed like that with new fill over in here. So you've got two overlapping caldera fills, and they're separated uh, by geochronology, by tens of thousands of years, 100,000 years, essentially insignificant time difference.
Sure. So,
But
okay,
it's a very complicated and very unique and probably the world's best exposure of a double trapdoor collapse.
double trapdoor collapse, and
Yeah.
that's only possible because you had that exposure and you had the trapdoor itself to work out that geometry, I assume. Um,
Yeah. Well, yeah. I mean, I had to find the overlapping deposits, and then I had to. Well, I mean, I interpreted based on what is in the field, right?
yes.
So whatever is in the field is what allows me to demonstrate that this is a double trapdoor. There, I got that image.
So, okay,
I
good.
should be sharing now.
You're multitasking now. This is good. Yeah, there's always a little delay when your image finally shows up.
And I'm drinking water.
Okay,
So let's start up here at the top corner, and we have the large magma body, whatever that looks like. We don't know what the magma body looks like.
right.
We just kind of have this form of magma that's accumulating underneath the surface.
Okay.
Um, and then for the trapdoor, the first trapdoor occurs when when one edge of what's going to be the caldera collapses on a fault, and all the eruptive products go out, the ash,
Yeah.
and that fills the caldera. That's the first caldera fill, which I called unit ignimbrite of Hannegan, THH.
Uh-huh.
And so then after the collapse, you've kind of got this shape of caldera fill. And then it begins to collapse on the other side, another caldera fault, more eruption over here. So you end up with the second fill on top of the initial fill. That's the ignimbrite of Ruth Mountain, THR.
Uh-huh.
And then, so you've got this stacked caldera deposit. And then now, 3.5 million years later, there's been all this erosion, plus the intrusion of two very young plutons.
How
So
young?
it's complicated as heck.
Yeah. Yeah.
And a textbook, except for the access, textbook place to study caldera structures.
Well, yeah. Would you mind stopping your share? Let's talk about that. So, just
Yeah.
the mechanics of this, the logistics of this. You saw the video with Hannah. She's trying to get brave enough to try to rappel down there. Were you rappelling? How were you working on that face that we saw?
I didn't have to, because those exposures are in other places as well that I could get to. So the thing about Hannegan is, for people who saw Hannah's video, that exposure is very loose stuff.
Yeah.
And I have been there 10 years ago and looked at that place with Wes Hildreth and with Judy Fierstein. I'm working with in the Simcoe and the Goat Rocks
Yeah.
on a previous project. And the thought of rappelling down that slope scares a bit Jesus out of me, because there's nothing solid for those trees to grow in, which would be your anchor. So
Yeah.
trying to rappel on a rope on a 4-inch diameter pine tree growing out of loose
Yeah.
loose humus deposits, no thanks. I
Yeah.
didn't have to do that at Hannegan.
Um, and which did you sample to get those ages, to get your geochronology at the Hanigan Caldera? How many different samples and what kind of dates, what kind of minerals are you using to get that precision?
So I'm using argon dates on biotite, that is in the rocks.
Okay.
And I collected quite a number of samples and collaborated with Geochronology Lab at UBC, University of British Columbia.
Nice.
I had grant funding once I started grad school. By the way, I already had 5 seasons of field work in when I started grad school, and finally got some money.
Wow.
I got a Kleinman grant from Cascade Volcano Observatory, which paid for my geochronology work. So that was on biotite for the caldera fill, and on zircons for the intruding plutons that I mentioned.
Well, this is so interesting and so helpful at this stage. I'm just starting to think pretty seriously about hop, skipping, and jumping between these places in Washington. If we go Baker, Glacier Peak, Rainier, Adams, and St. Helens primarily, like if I'm greedy, Dave, I would love to have similar stories at all 5 of those spots where there's a present cone, there's some sort of major pluton that's tens of millions of years older that this cone is built on top of. And then if there is a caldera in all 5 of those areas with some sort of collapse structure, like, is that unreasonable to expect that there's similar narratives with all of our 5 active spots?
Not necessarily. For instance, on the east flank of Glacier Peak is the Gamma Ridge volcanics,
Okay.
which are probably a caldera, but not studied.
Huh.
There's no caldera associated with St. Helens that we know of.
Okay.
And there is one caldera associated with Mount Rainier, but it's quite old. It's like 10, 15 million years old,
Okay.
and has also not been studied.
Yeah.
There's thick caldera fill type exposures, in the woods and on the ridges, but no one's really gone in there other than Paul Hammond, of course, who you've been hearing about,
Yeah.
who has pointed out a lot of these potential calderas, but just through his field work, but he's never published on any of it.
Huh.
So, are there calderas scattered throughout the Cascades? I believe there are. Paul and I collaborated on a GSA paper at GSA conference in Portland, where we outlined our sites that we believed were calderas in the Washington Cascades, from the Columbia River up to the border.
Oh,
Well,
wow.
actually, we extend above the border because there's probably a couple in the southernmost British Columbia. There's definitely one in British Columbia called the Coquihalla caldera, and that was probably the earliest one. That was the first one to be described in what we could consider the Cascade range. It's 15 million years old, if I recall.
Yeah.
Was not called a caldera at the time because the term wasn't used. Called a cauldron, which is like the British term. So if you search for cauldrons in the Cascades, you'll get one. If you search for calderas, you'll get a few, but you won't get that one.
Well, I'll find that document that you and Paul worked on.
I'll link you to it.
Yeah, thank you. That's where I'm headed, I think. And maybe a couple final thoughts about the calderas themselves, and then I'd like to do a little bit more personal history with you, if you don't mind, before we quit. So, what am I visualizing in a subduction zone when we get these high silica events? Is that clear what are the thoughts about, don't we have kind of business as usual with moderate silica content, and then occasionally we have these strange high silica stories? What's going on?
Well, we're seeing fractionation within the crust of, what are initially mafic intrusions, basalts, which, through crystallization and the whole process become andesites, or some of them become andesites. And if they have long enough residence time in the crust, and they fractionate, the mafic minerals dropping out. So the pyroxenes, kind of collapsing down to the bottom of this mush. You
Yeah.
end up with a much more silicic concentration at the top. And if that proceeds long enough, you end up with silicic rocks like rhyodacite and rhyolite. And so that stuff sitting in the very upper reaches of these mushes of magma are what erupt in very, very large scale eruptions. And they erupt in such a rapid fashion,
Yeah.
fracture in the crust, that the crust actually subsides, continues to pressurize the magma body, which continues to drive the eruption until all the really volatile gas-filled felsic material at the top is blown out.
Thank you. That's helpful. And in addition to those comments, I guess I'm remembering Hannah Shamlow's comment about the contribution of the crustal heterogeneity that these magmas are coming up through as another role. Like we're coming up through this fruitcake, all these exotic terrains. Like I wonder if you've got a really strange piece of exotic terrain material that your magma is dealing with, if that somehow is at all related to these.
Well, that would be assimilation. So, the magma body assimilating components from the crust it's intruding, but not necessarily. I don't think that's related to the caldera phenomenon.
Yeah. Thanks. Well, I'm going to keep rolling with this. Let's finish this out by just a little bit more. I knew about you initially more than a dozen years ago, I would say, reading your beautiful blog posts and your field trip. You spent a lot of time answering emails and doing all sorts of things kind of for the citizens of the Pacific Northwest. And that culminated in your beautiful book, Geology Underfoot in Western Washington. There it is. Thank you.
This is a nice copy. The ones with all the bug spatters in it and crossed out pages is in my book.
Yeah, right.
Is in my car.
Okay. Are you still at it? Am I missing it somehow, or have you backed off of some of that?
I've slid away a little bit. My interest in geology has always been on eruptive stuff, but a little backstory. When I submitted the introduction to my thesis to my advisor at Western, Sue DeBari, she got back to me within 10 minutes. I just walked down the hall to my office and she called me and said, "Get back here." And she said, "You need to decide whether you are writing a scientific thesis or if you're writing a guidebook." And that's when I realized that my real interest was education, geology, just like you, although I don't do podcasts. And that's when I realized that that's really what I enjoyed doing. So I started the Mount Baker Volcano Research Center, a nonprofit which has folded, but to kind of do public education about Mount Baker, specifically eruption hazards and the history of the volcano. And then from there, it kind of evolved into a website, Northwest Geology Field Trips, which I haven't been posting to so much, but I do have a bunch of material that I need to get up. And in writing that book, which fell into my lap, the publishers saw my website and they asked me to write a book. I didn't even have to sell it to anybody. That was nice.
Right.
So, I'm a people geologist. I like talking to people who don't necessarily have a whole lot of geologic background. When I started working with Wes, I was just like the people who love your show. I was a citizen who wanted to know more and didn't know how to go about doing it. And I didn't have you to listen to in 1994. So here I am.
Yes, and you provided a great service to so many of us, myself included, back then, and I'm continuing to learn all sorts of stuff from your writing. So thank you so much for that, Dave.
It's fun.
Yes. Thank you for your time today. Please hold the line. I'm going to stop the recording and we can just keep chatting a little bit, but let's wrap this recorded interview by simply saying plenty more to learn from you, I think, and many others who know about the Baker area. Thanks so much for your time today, David.
Great, Nick. Happy to talk to you.
All right.
See you next time.
Bye bye.